For problem number 3, we can see that the equation is not in the form that we want it in, so we want to get it in y equals a times the sine of bx, b, times x minus c. Now, just like the last video, we have to factor out whatever that coefficient is in front of the x. And factoring it out, we move it to the front, and that's our b position. And then if we factor out a 2 from a 2x, we're left with just x. If we factor out a 2 from pi over 3, there's no 2 there, so let's put a 2 there. And if we put a 2 there, we have to put a 2 in the numerator, we have to also put a 2 in the denominator. We're not changing the value of the fraction, we're just changing the look of it so that it would be easier visually to see, oh, there's a 2 there, we're going to take it out, and then whatever's left over, pi over 6, is what you get when you factor a 2 from pi over 3. So it's just kind of an easier way to see it, perhaps. And you don't have to do that, but definitely it's easy to make a mistake when you're factoring out a 2 from a fraction. So I just like to visually put it there, and then I make many fewer mistakes? Fewer mistakes. All right. So that's step 1. We have our equation in the form that we need it in. And this has a little bit of everything in it. So we have our a value, we have our b value, and we have our c value. So just like the previous videos and the instructions, just follow the steps, and it's really hard to go wrong if you just follow the steps. So we're going to find the period, and we're going to plot it. So the period is, again, 2 pi over b, and the b value is 2, so we have the period being pi. So let's find and plot that. Again, we're going to kind of prep for the near future, because we're going to be moving the whole graph to the right, pi over 6, so we can put our y-axis way over here to the left, because we're going to be shifting the graph all the way to the right, or a little bit to the right, and we want to leave some space to the right of where we put our period. So our period is pi, and then we're going to divide the period into 4 equal sections. That's the next part, part 3. And so we cut pi in half, we get pi over 2, cut pi over 2 in half, we get pi over 4, and then we've done this before, 3 pi over 4 is halfway between pi over 2 and pi. So we've divided our period into 4 equal sections. Now we draw the midline. Again, the midline is y equals d is 0, so the midline is the x-axis. Find and label the amplitude. Now the amplitude, we finally have one that isn't just 1. So the amplitude is the absolute value of a, and a is 3, and so the amplitude is 3. Amplitude is always going to be a positive number. A could be negative, but the amplitude will be always a positive number. But look, I don't do anything differently. I don't move it way up there. Now it's not going to be proportional, but it's going to be a way that we can get exactly the coordinates that we need just by plotting the amplitude of 3. And 3 above the midline and 3 below the midline. There we go. We have our amplitude labeled. Now draw the sinusoidal graph without the shift. All right, so we're going to draw the graph of y equals 3 times the sine of 2x. That has a period of pi, amplitude of 3, and the sinusoidal graph, since I did not say this on problem number 1, but sine graphs always start at 0, 0, because the sine of 0 is 0. All right, so we're going to always start here for the sine graphs, and cosine graphs always start at off of the origin. So either way up here if a is positive, or way down here if a is negative. But if a were negative for the sine graph, instead of going up, we would go down first. It would be a reflection over the x-axis. So anyway, graphing this function here, we have from the midline we go up to the high point, back to the midline, back to the low point, and then back up to where we started. So this is the graph without the shift. That's all you got to remember, is just do the graph without the shift. Do it dotted, so then there's no confusion as to what your actual final graph actually is. Now we're going to shift the graph to the left or right C units. Well, we know that when x is replaced with x minus something, we know that that something gets shifted to the right if it's minus in front and left if it's a plus in front. So this one is moving to the right, pi over 6. Now this is a little trickier, but what we can do is get by with, think about where pi over 6 is in relation to pi over 4. So if we look at the unit circle, the pi over 4 angle is the 45-degree angle. The pi over 6 angle is 15 degrees lower than that, so that's the 30-degree angle. There's the 45-degree angle. And so it's closer to pi over 4 than it is to 0. So if that helps you. And it's like from 0, it's 2/3 of the way to pi over 4. So if you think about it in thirds, that's your pi over 6 angle. So a third of the way to pi over 4 is pi over 6. So we're moving this whole graph to the right, pi over 6. So that point right there moves to the right, pi over 6 radians. Now, each of these subsections gets divided into 3 equal sections, and we just move to the right 2 of those 3. Okay, so 2/3 of the way to the next subsection point. So we have right here, pi over 2, 0 becomes whatever that is. We can add we're going to go 2/3 of the way to the next subsection. We're going to put a point right there. And then down here, we're going to move 1, 2, 2/3 of the way. And then here, the next would be here 5 pi over 4, but we're going to go 2/3 of the way to 5 pi over 4. And it would be nice if we could just make sure we label the starting point, and we'll also label this guy. So what is pi plus pi over 6? What is pi plus pi over 6? Well, 6 pi over 6 plus pi over 6 is 7 pi over 6. So what I need you to do is label, is a little trickier, label though the starting point coordinate and the ending point coordinate for the one period of this function. All right, so we've moved everything to the right. All we have to do is now shift the graph to the right by going through those 5 key points. So that's what I'm going to hold you guys to. That point right there, pi over 6, 0, and 7 pi over 6, 0. Without labeling the starting and the ending points of your function, sometimes it's hard to tell if you have the function in the right spot. So that's the reason why you need to make sure you label, at least label the starting point and the ending point. If you want to go through and find all these values here, that's it's totally up to you. But because we can see the starting graph without the shift and then the ending graph with the shift, I think that's fine. Just having those two coordinates there, pi over 6 and 7 pi over 6. And clearly we can see the graph hits the x-axis at those values.